Welcome again. This is Stefan Bortsmaier from AVNIC. He's going to update you, or if you've never heard him talk before, inform you on the state of DNS privacy.
As soon as I... Okay.
It's private now.
Yeah, exactly. So, hello. So, there have been a lot of talk at FOSDEM or everywhere about many aspects of internet privacy. For instance, on web privacy, you've read a lot of papers, a lot of talks, but DNS privacy is still today something which is typically forgotten by most people when they talk about privacy. For instance, I tried to get the National Data Protection Authority in France interested in DNS privacy, and until now I failed. Why? Part of the reason is because they are very busy with web privacy today. There are already a lot of work, but DNS privacy seems to many people a technical detail. So, but it's not, of course, you can imagine. So, the biggest problem of DNS privacy, in one slide, first is that DNS protocol is unclear most of the time. Today, most of the internet traffic is encrypted. I hesitate to say most of the DNS of the internet traffic because we don't really know. But for instance, Firefox telemetry reports that now a typical Firefox sees around 70% of HTTPS, 30% of HTTP. And of course, many people go through a VPN, IPsec, etc. So, most people now manage their machines with SSH and not Telnet. So you can probably say that most of the internet traffic is encrypted today, which is good, but DNS is still unclear most of the time. That's a problem. Also, DNS is too talkative. A typical example is that too much information is sent. For instance, the fully qualified domain name FQDN, which is something that something that something that something else, that example, is sent to all the authoritative name servers starting to the root. So if you have access to the pickup of the root name servers, which is quite easy if you are, for instance, a DNS.org member, you will see that a lot of requests go to the root, even if they are not necessary. I mean, the root knows only about the TLD, so there is no need to send the complete fully qualified domain name. And speaking of that, all of the DNS tutorials for dummies that you can find on YouTube are wrong. Because on all the DNS videos that you can see on YouTube, you can see the DNS request sent to the root is only the TLD. This is not true. A real resolver today sends the complete fully qualified domain name. So DNS is too talkative, and some requests are very, very revealing. If you run TCP dump or similar program on your authoritative name servers or resolvers, you will see, for instance, that there is at least, this is a real example, there is at least one BitTorrent client which requests a SRV record, so this name, for the domain it is in. And this is typically information that many people will regard as sensitive. I mean, I could sell this to MPAA or organization like that. This guy is using BitTorrent. It's bad. So some people believe that most DNS requests are not sensitive. For instance, a request for GoogleAnalytics.com is not really sensitive because, unfortunately, all the websites are using Google Analytics, so it proves nothing. But other requests are much more damaging. And of course, even some very perfectly legal domain names can be sensitive. Also, an important point about the DNS is that many people forget it, is that the DNS requests travel outside of the normal path. For instance, if you are a French user in France and visiting a French website, you may assume that all your traffic stays inside the French border and so is subject to European data protection laws, etc. This is not completely true because you know that the routing on the internet is something complicated. Traffic between a French client and a French hosting provider may go through AM6 in the Netherlands or links in Great Britain, but because of the DNS, it's even worse than that, because the request for the DNS will go in much more autonomous system than the typical connection between Alice and Bob. For instance, if the domain name is a .com, you will go to the verified name servers, which probably do not abide by the European data protection laws. There have been some surveys. I think that Laura Roberts from the University of Princeton did a very good survey of how many AS, autonomous systems, so basically network operators, how many autonomous systems are traversed by a typical DNS request, and it's typically 2 or 3 times the number of AS crossed when you go from the HTTP client to the HTTP server. And it can be a problem because many people forget about it. And many people don't have what I could call DNS privacy sensibility. Another survey by the people of the University of Princeton showed that 1/3 of Tor exit nodes are using Google Public DNS as a resolver. So you set up a Tor exit node because you care about privacy, and then you configure Google Public DNS as a resolver. Okay. In one way, it's normal because you cannot, when you are a Tor user, you cannot be sure of what the exit node is doing. But it typically shows that most people are not really aware of DNS privacy issues. Yep. Aha. Better. Okay, I have to keep clicking on some key time to time. So, for instance, things like Schengen routing, the idea that you can limit the traffic inside European countries with proper data protection laws, it's very difficult in general, but it's even worse in the case of the DNS. So, what have we done to limit the problem, to tackle the problem? As far as I know, the first time that DNS privacy was mentioned in an official meeting, if I say, was in June 2013. At the center is the Association of European TLD Registries, and there have been a talk about DNS privacy. Is it important? Does it matter? At this time, even center members, who are all professional of domain names, were not aware of the issue. So it was a beginning, and funny enough, almost the same day, some American guy flown from Hawaii to Hong Kong and settled in a hotel room and then called journalists to report about that there was some organization which was actively surveying the internet. So inside this revelation, one of the programs was not... Okay, battery down already. Inside this revelation, there was one program which was missed by most people. It's called More-Cobel. And More-Cobel is the surveillance using the DNS. It has several parts in More-Cobel. Like all the NSA slides, it's quite difficult to understand what's going on. But apparently, they use both active reconnaissance in the DNS and also passive surveillance by watching the DNS traffic. So we were not the first to notice that DNS is good for surveillance. NSA noticed it before. So November, at the IETF meeting in Vancouver, it was the beginning of a project about increasing DNS privacy. It was quite informal at this time, but most IETF, if you've never been to IETF meeting, you have formal meetings, working groups meetings, which are typically quite boring, and then people gather outside of the rooms and drink beers, and this is where the actual work is taking place. So, for instance, as often in the internet, code comes before specification. That's the usual way of working. So for instance, in March 2015, if I'm correct, the library GetDNS, which was presented by Willem a few minutes ago, already implemented DNS over TLS, allowing you to encrypt DNS traffic. In August 2015, release of the first RFC about DNS privacy, 7626, which is a description of the problem. It's not a solution. The general way of doing things at IETF now is first to describe the problem, then to find out solutions. In the real world, it's more we write code, Then we maybe write specification, and at the end we document the problem. But if you want to know about DNS privacy, if you want a reference which is much more detailed than this talk, you should read this RFC. Then in October 2015, Unbound, the Unbound resolver also had DNS over TLS. Actually, it already had it a long time ago using non-standard things, but this is the time where it switched to the official port for DNS over TLS, which is 853. So if you see traffic on the network directed to port 853, it's DNS over TLS. Next year, one way to improve actually DNS privacy was RFC 7816, which is minimization of the queue name. As I said, today almost all the DNS resolvers send the full DNS query to the root and then to the authoritative name servers. The idea of this RFC is stop doing it, send only the minimum. When you talk privacy to typical engineers, they have only one answer: encryption. That's the solution to every problem. Actually, encryption is a very good thing, encrypt everything, I agree, but it does not protect against anyone. For instance, it does not protect against the endpoint. Doing HTTPS with Gmail is pointless if Gmail sends your data to the NSA. They won't do it, of course, but if they do, encryption won't protect you. So when you talk about privacy, you need actually to do two things: minimizing the data, sending less data, collecting less data, and also encrypting it in transit to protect against the sniffer. So the idea of this RFC is stop sending to the name servers everything. Send only what they need to know. So for instance, the root name servers, because they know only about the TLD, they should be asked only a query for the TLD, not .bittorrent, .something, .example. Same year, specification for DNS over TLS. Remember that there was running code before, but okay. So DNS over TLS, the idea is to encrypt DNS traffic, of course, running on a specific port, and it's also standardized only for the stub to resolver link. Remember the talk by Willem about GetDNS this morning? GetDNS is for the stub, which is the part which runs on the user's machine. Then the stub talks to the resolver, which is typically managed by your ISP or your university, and then it goes to the authoritative name server. So DNS for TLS at this time is only standardized for the stub to resolver link. Part of the problem is that resolver to authoritative makes authentication more difficult because one stub talks to only a few resolvers, but resolvers talk to thousands of authoritative name servers. And then also there is this option, padding, because one of the big problems of TLS is that TLS makes no attempt to disguise the size of the answer. There have been many scientific papers about how you can find out what people are doing even when they use HTTPS. For instance, when you visit Wikipedia with HTTPS, you can find out what page were requested because the size is not disguised. So someone who wants to know about you can do the same request, get the size of the files you get, and then knowing what you are visiting if it is something that is public. And of course, the DNS is public. So just using DNS over TLS may not be sufficient if you don't do some padding, which means that you fill packets with useless bytes. So this is the past. No, not completely. Also, in July 2017, it was a release of Stubby. Willem talked you about Stubby. It's a daemon that you run on your end-user machine and which forwards requests over public or other resolvers. I didn't mention systemd resolve because as far as I know, they did nothing for DNS privacy yet. So this is the past. Now the present. What is the current situation? On the technical standard side, we are not completely done. There are still things to do, but we have already a consistent set of technical solutions to improve DNS privacy, especially the two things I was mentioning, minimizing data and encrypting it. We have RFC for that, so we have at least a standard. Now, a standard, of course, is not sufficient. You have to implement it. So you need running code. So we have running code. We have running code in servers, such as a note on Unbound. We have running code in libraries, such as GetDNS mentioned this morning, or if you prefer to program in Go. Yesterday I was at the Go dev room. It was completely full. It was closed, the morning it was closed 30 minutes before we started, because Go is a very popular language, and there is a very good library to do DNS in Go, written by a Dutch guy, because most of the DNS code is either Dutch or Czech. And GoDNS is a very good library with a lot of features and DNS over TLS among them. So we have running code, but sometimes this code is a bit rough. If you take, for instance, the Unbound DNS resolver, Unbound can talk DNS over TLS to an upstream server, but it creates a new TCP on TLS session for each request, which obviously doesn't scale when you have a lot of traffic. It's clearly a problem. So this is the sort of thing that have to be improved. Also, this is a code, TLS is used a lot, of course, but DNS over TLS, few people are using it, so probably there are many bugs still waiting to be discovered. So some work on the code is necessary. Also, as far as I know, there is nothing in bind, but I certainly hope that Andre will fix that and add all sorts of interesting privacy features in bind. We have also at least one big public resolver which is using DNS over TLS. It's called Quad 9 because the IP address, well, if you use the old IP protocol, the one in the very old IP protocol where the name were only, where the addresses were only 32 bits, the address is 9.9.9.9. They have also an IPv6 address, but it's more difficult to memorize it. So Quad 9 is already working. As Peter remembered this morning, the DNS over TLS support is not official. So Quad 9 is officially supported, but DNS over TLS, it's not even documented. You have to discover it by Nmap and things like that. But it works. And also there are a few other small ones, for instance, LDN, which is not-for-profit ISP in the east of France. They provide a public DNS resolver with DNS over TLS. So we have some possibilities. We have QNAME minimization in at least two resolvers, Unbound and not. In the case of not, it's by default. In the case of Unbound, it's not by default. You have to edit the configuration file if you use Unbound directly from upstream. But most people, of course, don't type configure, make, etc. They use a package for their operating system. So if you use Debian, for instance, the Debian package of Unbound comes with the default, which is QNAME minimization. So in that case, it's better. But if you do measurements, for instance, with WIPE Atlas probes, which were mentioned this morning, limiting yourself to Europe, where probably people are more often using this sort of features, only 2% of the probes in Europe have a resolver with QNAME minimization. So we can say that the deployment, actual deployment, is close to zero at this time. We have a website, very important. We have a website, actually an information portal. So if you want to know about DNS privacy, the standards, the code, the servers, the papers, etc., you have only one point to visit, which is dnsprivacy.org. But the actual deployment is very limited. So encryption is very rare, QNAME minimization also. So we are quite late when you compare to the HTTP people, for instance. The future now. We have several RFC which are almost done. One is authentication of the DNS over TLS resolvers. At this time, the only standard way is by key pinning, remembering the key and using it, which is, of course, quite brittle. For instance, Quad9 changed its public key on Friday when renewing the Let's Encrypt certificate, and they got a new key, breaking all authentication. So in the new RFC, which will be published in the next few days, we will have several methods for authentication of DNS over TLS resolvers. This one is almost done. There is also one on padding profiles. Padding is great, but you have to know how to pad. I have seen sometimes software padding to defeat traffic analysis, and for instance, padding with a constant length of padding. Every request was padded with the same amount of bytes, which is obviously useless. So there is an entire RFC dedicated to what are the clever ways of padding. And this one is also almost done, so it should be published in the next months. Time to mention GDPR. Nobody did yet. Yes. So May is also an important moment because that's the time where the GDPR comes into force. At this time, all the people who are walking, talking, panicking over the GDPR never pay any attention to the DNS. So we can safely say that if we are DNS professionals, we won't see lawyers in June asking to us about DNS privacy, what are we doing, do we really do everything what is to be done according to the GDPR. But in the next months or next years, maybe people will start paying attention, and I suggest that it's better if we do something about DNS privacy before the lawyers came in. There is also some work at the IETF. Unlike the two first RFC, which are close to be over, this work about encrypting the resolver to authoritative link, well, it's far from being done. So it's not even clear if there is enough interest, steam, etc., to work on this. We will discuss this at the next IETF meeting in London next month. Speaking of running code, Android has code for DNS over TLS. It's already committed in the public repository of Android, but it was not in Android released version yet. And also there is DNS over HTTPS, which is under standardization at IETF, and unlike the encryption of resolver to authoritative link, it seems there is a lot of interest for DNS over HTTPS because one, it goes through firewalls, unlike port 853, which may be blocked, and also it allows JavaScript developers to have the full power of DNS. So DNS over HTTPS seems interesting for a lot of people, and at the next IETF meeting in London in March, there will be a hackathon, as always, and probably a lot of people at the hackathon will work on DNS over HTTPS. As I said, we have several bricks for DNS privacy. One interesting point is how we put these bricks together. For instance, what resolver, where should we validate with DNSSEC? Where should we encrypt? Which resolver should we use? Ordinary people today use the ISP resolver, which may be a problem because most of the time they don't have DNS over TLS, they don't do queue minimization. You don't always know what they do with data. So you can have another solution is to have a stub running on your machine talking to a public resolver like Quad9. Quad9 has DNS over TLS, but what do they do with the data that you give to them? You don't know. Well, actually, there is a public policy. It's funny when you read the privacy policy of Google Public DNS on Quad9, they are exactly the same down to every bit. So someone copied the other, I don't know which one. And all of them promise a lot of things, but it's hard to know if they stand by their published policies. Also, you can do things locally. you can buy a Raspberry Pi, install OpenBSD, Unbound, Stubby, everything on it, and do everything locally. The good thing is that you control everything. The bad thing is that, first, it's today a bit too difficult for the ordinary user, especially the OpenBSD part, and also it does not completely protect you, because then all your requests to the authoritative name servers will come from your own IP address. So on a privacy point of view, it may be not always the best solution. But several solutions are possible. For the first part, the difficulty, one possible solution is to have everything in a box ready, such as the Teresomnia, for instance. The Teresomnia comes from such a resolver. Also, you can have a mix of several solutions. A possible solution, for instance, is to have Stubby. One good thing about Stubby is that it can switch between several public resolvers. So you still entrust these resolvers with your data, but you spread it on several resolvers. And the next version of Stubby, if I'm correct, will be able to randomize the choice of the resolver. So today it's done in a round-robin fashion. Also, should we use DNS over TLS, or, of course, should we run everything over port 443, which is allowed by DNS over HTTPS? This is FOSDEM, so people are supposed to know that we have to work. So we need you. Most of the standard work is done. There is still work to do, but most is done, but we need code. So for instance, now that the bind code is on the GitLab public, you can send pull requests to add privacy features to bind. And of course, code is not enough. You also need deployment. So do it, just do it. And of course, we need outreach, talking to people, talking to data protection authority, to data protection officers, etc., about the importance of DNS privacy and what to do. Sorry, I was a bit long, but still maybe have some time for one or two questions.
Yes.
Bert?
Yes. Hello, Stefan. Thank you very much for your wonderful presentation. Now that we're all here, first I want to say we really DNS dist also has a TLS module these days. That means you can put DNS dist in front of any name server, and it will gain high performance TLS for DNS tunes. But you can use HA proxy as well, but this is sort of more closer to DNS. And the other thing, could you go back to slide number 6? Okay, I didn't know it was that one. Okay. Android released with DNS over TLS client. Wonderful news, wonderful news. We must all deploy DNS over TLS ourselves. Android and Google are not our friends in this way. As you noted, the encryption to Google is fine. What happens then, we don't know. What we do know is that eventually they will say, your provider has weak DNS privacy. Your Android phone will now connect straight to Google for DNS. And they're open about it. They're just telling everyone this is the plan, and it's all great for privacy for everyone, super wonderful and nice. This brings me to the excellent Google privacy policy on DNS. It is excellent, it is true, the people that work there guarantee me it is true. It says nothing about tomorrow. So the whole page says your privacy DNS or Google is fine right now.
Until
tomorrow. So they say nothing about we will give you a year of warning if you start data mining your stuff. There's nothing about it in there. So eventually someone over there could wake up and say, glorious data. I'm going to use this. So my call to you is, everyone, if you work at a service provider, I see a few of you here, please deploy DNS over TLS as soon as you can. Because we do not want to have this situation where Google can legitimately say, please give us more of your data so we can protect your privacy better. Thank you.
Just a word about the third party of the problem of sending your DNS queries to Google or to a specific central authority, like the public DNS route. There are actually several alternative DNS routes, like OpenNIC, OpenRoute, New Nations, and maybe you have some opinion about this kind of alternative DNS routes.
OpenRoute will be fast, pure scam, nothing. So there is nothing to say, it's a pure scam. For OpenNIC, it's a bit more complicated. They use a non-standard encryption. So I don't like that because I prefer standard solutions where there is interoperability, where you can choose your software. And also they mix privacy with other things that I want to promote, and typically it's alternative route, which means that they also add their own TLD, which may collide with other TLD. So it's that in my book it's not good.
Last question.
Yeah.
You mentioned GDPR. In the context of that, in terms of ISPs and Wi-Fi providers, are they likely to I think they would be affected by this in the sense that, first of all, GDPR means that they can only do what's needed to provide the service. So, like some of the ISPs in the old days used to, for typo domains, that would redirect to adverts and stuff, that wouldn't be allowed. But also, are they going to be likely required to, for example, prefer upstream internal EU servers? For example, root servers prefer using EU-based root servers versus US-based root servers, either in preference or in totality. To fit in with that because the data, is kept within Europe. And on the other side of it, whenever DNS becomes across the board, that's going to present problems within countries because, for example, in the UK, we have the government-mandated DNS blacklists that, by law, the ISPs have to enforce. But if everything's encrypted and the ability of me to not use my ISP to go direct, I can see the pushback where ISPs will be required to prevent me from not using their upstream server, so then they can actually do this blacklisting that they're being forced to by the governments.
Okay, there are two things. One is for GDPR. I'm not a lawyer, but my guess is that it will be several years before the lawyers or the DPO or the Data Protection Authority will really go into what's going on in the DNS. At this time, we are allowed. And most people won't be interested in DNS before some time. So we don't have to expect a big change in May for the DNS guys. I mean, still, some of the provisions of DNS Privacy Project are very well aligned with GDPR. Typically, QNAME minimization is sending only what you need. So it's a good idea to do it. Now for the risk, well, the rest is more a political problem. Indeed, one of the risks in the future will be ISP blocking port 53 or 853 because they want to monetize your data or because they are government mandated to do so. It's possible, or even interfering with DNS resolution like it's already currently done in China, for instance. That's one of the motivations for the DNS over HTTPS project. And there is even some reflection about how to make DNS over HTTPS indistinguishable from other HTTPS traffic, precisely to address this sort of issues. But it's more a political problem. For instance, blocking port 53, for me, it's a net neutrality problem before everything, before the DNS privacy problem.
Thank you.